Hey guys, I'm coming going doing this AP math gameplay again, round 2. This I had a little bit of lag in doing this problem. It took me like an extra 2 months to upload this video, but you know what they say, better to uh better to do it than never have done it, by Abraham Lincoln. Anyway, today we'll be doing oh my, I can't even read the problem. Freaking set, get out of here. Freaking set always here. Set Adobe, always taking on display. Okay, there we go. Now we can read the problem. Alright, so we're doing chapter 9, 2007, number 3, AP free response. Alright, let's read this problem. Alright. Big Town Fisheries recently stocked a new lake in City Park with 2,000 fish of different sizes. Distribution is pretty normal. Alright, part A. Big Town Fish claims that the mean length of the fish is going to be 8 inches. If the claim is true, which is more likely, that a random sample of 15 fishies is greater than 10 inches or 50 fishies? Now, I've seen Finding Nemo. The fish aren't actually all 8 inches, but, Big Town Fisheries, they're different. They're different kind of group, I guess. So I got all the answers on this Google Notepad thing, and I wrote my own answers here. So basically, for this problem, what we want to look at is the only thing that's different is sample sizes, and they're trying to claim that it's greater than 10 inches. Now, if the thing here that we gotta look at, since they have different sample sizes, is that this 50 fish is bigger, like it's closer to the population of 2,000 fish. It's not like super big, but it's more representative of the population than 15 fish. So because of that, you can have a lot of variability in the 15 fish sample, and with that variability, it'll affect all the data really quickly, really badly. You know what I'm saying? So like, if you have one fish, if you have one fish that's like 300 inches long, then in the 15 sample data, everything will be skewed more than in the 50 sample data because of how many fish there are to, just compare with. You know what I'm saying? What is this? Okay, anyway. So, yeah. So basically, because there's a larger sample, the data, one like big fish won't skew it as much as uh, in a 15 sample. So because of this, we can conclude that it's more likely that you're gonna have, if you have like if you have like a bunch of big fish in this one, uh, it's more likely to have a mean greater than 10 inches than if you have a bunch of big fish in this one, because there's still gonna be a lot of fish that are still small, and so therefore the variability, it impacts a smaller sample more than a bigger sample. All right, part B. Suppose the standard deviation of the sampling distribution of the sample mean for random sample sizes of the thing is zero point 0.3 inches for size 50 in the sample. The mean length of the fish is 8 inches. Use the normal distribution to compute the probability that a random sample of 50 fish will have a mean less than 7.5 inches. So this is just straight up just you use a formula. So all you gotta do is you do this. You guys probably like looking at that. You guys probably
What do
like,
you mean?
what do you mean? You know what I'm saying? Like, you probably don't even know what that means, but it's really simple. So what you're looking for is if the mean length is less than 7.5 inches. So you don't. So that's what we're calculating here. And so what you want to do is you want to have the sample here 7.5 inches minus the average that we know 8 inches. So you'd have that minus that. Divide that by the standard deviation, and you're going to have negative 0.5 over zero point 0.3, which equals to negative 5 over 3, because you just have the decimals here. They don't really do anything. So negative 5 divided by 3, that's just negative 1.666, because a third is 0.33. So you can calculate that, and then You don't want to have negative 1.666 because that's a pretty spooky number right there. Don't want, you don't just get this. You don't want that. You just want to round it up to this instead. This is more reasonable to have because it's not a spooky number. And then you just go to your z-score table, look this bad boy up. That's what you get. And so that's what you need to solve this one. And then part C. Suppose the distribution of the fish lengths in this lake was non-normal, but had the same mean and standard deviation. Would it still be appropriate to use a normal distribution? In part B? Question mark. Alright, so the answer to this is yes, because of the central limit theorem. Basically, if there's like a large sample, and we have a sample of 50, that's large enough to say that that it's going to be close enough to normal, and so be it. So basically, these are the answers, and with the AP answer key, it matches all of the E's. Don't get a single thing wrong. Basically, we talked about how variability in the sampling distributions works. So we got that baby. Part B, we showed the math. You can also show a graph if you want that. But we showed evidence of calculation. So that's pretty cool. And then for the last one, we had to talk about CLT and Hodder. First, a large sample size, and we do have a pretty large sample size in this case. Alright, so you know what time it is. It's time to make sure that we're right on our math, and we gotta call up a math professor. So we got two guys here. We got this guy, Sadobi. Right from the get-go, you know, this guy is intimidating. I don't want to call him. So let's call this guy. See, this guy is inquisitive. He's thinking about life. So we want to call him up. Right, that's actually pretty scary, dude. I don't want to call him. He's a pretty. I'm too scared, dude. What if he makes fun of me? Anyway, guys, this is like, comment, subscribe if you want more. Thanks to Burger King for funding this thing. Make sure to donate if you want to see more of these videos, and make sure to donate more so this can be my reality forever. So thanks everyone.